Hi everyone! In this lesson we will look at angles formed by parallel lines and a transversal, and we will refresh your prior knowledge and then we will expand on it. So grade 9, let's start with our parallel lines. Okay, so here we have a pair and you can see 3.5 centimeters apart, so they will be the same distance apart everywhere. They run into the same direction, so this two, they will never cross. The same over here, they run into the same direction. There you can see to the left, to the right, the same distance everywhere between them, and they will never meet. This two, they run on a slant, but they will never meet. 2 centimeters between them all the time. So we say parallel lines never cross, they never meet, and they run into the same direction. And lastly, if we measure any place, you see there, any place, they are the same distance apart. Next, here we have two pairs of parallel lines. They run into different directions. This two up and down, this two to the left and to the right. Okay, so to show that lines are parallel, we mark them the same, and I will do that now. We make it white. Okay, so these two lines I will mark with one arrow. These two lines I will mark with two arrows. So you know we have two pairs of parallel lines there, and this is my first pair and that is my second pair, and for that reason I mark them differently. So we also get non-parallel lines. Look at this two here. If I extend this one, they will eventually meet. The same over here. If I extend this line, it will meet the other one. So we call this non-parallel lines, and sometimes lines are not parallel. We call them non-parallel lines, and if we extend them, they will eventually cross. Right, now I want you to look at these two lines here. Here we have two lines, and we have a third line that intersect or cross. Yeah, they intersect at 2 points here, or it passes through 2 points over here. Now this third line, we call that our transversal. Now what is a transversal? A transversal is a line cutting or passes through 2 or even more lines. Right, so we call this our transversal. Then something else about this figure here. You see the transversal cut the two lines, and immediately we have many angles here, but no relationship between the new pairs of angles. Now you know already that vertically opposite angles, they are equal. Adjacent angles, they are equal to 180 degrees. But now we have also quite a number of new pairs, but they will have no relationship if the lines are non-parallel. It's a different matter when the lines are parallel, and we look at that now. The relationship between pairs of angles formed when two or more parallel lines are cut by a transversal, they are, and we'll start first with this pair. Right, but before we get there, I'll read this. AB, you see there, line AB is parallel to line CD. That is our symbol for parallel. Okay, so we have now many angles. When parallel lines are cut by a transversal, many angles are formed. Now there's a relationship that exists between these pairs of angles. And what do I mean by that? Some will be congruent and some will be supplementary. Congruent means some of them will be equal. Supplementary means some of them will be equal to 180 degrees. Now we start with our first pair. Here we have the corresponding angles. So let us revise the 3 new pairs of angles formed when 2 parallel lines are cut by a transversal. So the first pair is our corresponding angles. Now they are in the same position at each intersecting line. You see here, that's our parallel lines. That is our transversal. This one is on the right hand side of the parallel line. That one on the right hand side, both above the transversal. Same position. We'll take another one. That gray. Okay. Below. Both of them below the transversal. Both of them on the left hand side. So the first pair is on the right side of each parallel line and above the transversal. The second pair is on the left side of a parallel line, or the parallel lines below the transversal. We have another pair here. This time the transversal is over here and we have our parallel lines running into this direction. You see, one is now above and the other one is also above, but both on the right hand side of the transversal. Then we have another pair. You see here, below the parallel line, and on the left hand side of the transversal. Right, and that is how we look at them. They are in the same position at each intersecting line. Above, below. Right, below the line, above and above. On the right hand side, on the left hand side of the parallel lines. Now the second pair of angles that is formed when a transversal cuts 2 parallel lines, they are alternate angles. This four, right, we call them the exterior angles. They are on the outside of the parallel lines. This four, the interior angles. Now the alternate interior angles are in between the lines and on opposite sides of the transversal. You see there? And I'll give you a pair, 3 and 6. In between, opposite sides. Another pair, 4 and 5. We call them alternate interior angles because they are in between the parallel lines. Then we also get alternate exterior angles. They are outside the parallel lines. On opposite sides of the transversal, 2 and 8. Alright, exterior. 1 and the opposite exterior, 7. Right. Now parallel lines can also be cut by 2 transversals. So here I have one in yellow and a one in red. Right. So we start with the alternate exterior angles here. B, and here's our yellow line, and it will be this one over here, J. They are alternate exterior angles. We have another pair, A and K. Right, so A and K and B and J. They are the alternate exterior angles. Now we move to the inside, in between these 2 white lines. You see here, one on the one side, one on the other side, but in between the parallel lines. So C and G, they are alternate interior angles. We have another pair, F, but now watch this one. From the parallel line to the transversal, it must be the yellow transversal in this example. Then again, from the parallel line to the same transversal there. So F and D plus E, they are alternate angles, right? F is alternate to D plus E. So always be careful when one of the angles is divided into two or more angles, right? As long as you remember from the parallel line to the transversal, parallel line to the same transversal. We take the next lot. Let me just clean that part quickly. Right. We have another pair, E and H, right? E and H, and I from the white line to the red, from the white line to the red, or rather, from the parallel line to the transversal, from the parallel line to the transversal, and I is alternate to C plus D. Alright, so it's C and G, F and D plus E. Next pair. Alright, now the third pair of angles that is formed when a transversal cuts two parallel lines, they are the co-interior and co-exterior angles. Now we find the co-interior angles also in between the lines. Right, interior, in between the lines, but they are on the same side of the transversal. So you can see they're not adjacent angles, they're non-adjacent angles. Right, so it will be this one and that one. From the parallel line to the transversal, from the parallel line to the transversal, in between. Right, okay, and I'll give you a pair, 1 and 2. Right, let me just clean that white lines there. So it will be 1 and 2. There's another pair, and it's 3 and 4. So it's between the lines on the same side of the transversal. Now the same with the co-exterior angles. This time they're just outside the parallel lines, but they're still on the same side of a transversal. Right, and I'll give you one example, 5 and 6. You see, same side of the transversal, both above, but both outside the parallel lines. Here we have another example where we have more than one transversal here. We have a blue transversal and a yellow one. Okay, so this pair is in between on the same side of a transversal, so it is A and E. You see there? A and E. Then we have another pair, C from this white line to the blue line, from the white line to the same transversal. So C plus B plus A. They are co-interior angles. Okay, so it's A and E, co-interior angles, and C and A plus B. Right, that too. C, B, and A, they are co-interior angles. Now we are going to look at the relationship between each pair of angles when two parallel lines are parallel. Two lines are parallel, right? When two lines are parallel. Now remember, they are or equal to 180 degrees. That is the relationship. Okay, now we already know, same position, they are corresponding angles. In between on different sides, alternate interior angles, alternate on the outside, both exterior, and on opposite sides, alternate interior or exterior angles. Alternate interior, alternate exterior. Then we have our co-interior angles, same side of the transversal, or they are both in between the parallel lines or outside the parallel lines. Right, let's look at the relationship. First of all, you know when two lines intersect, vertically opposite angles are equal, and adjacent angles, they are equal to 180. So if this one is 130, this one must be 50 degrees. Right, adjacent angles on a straight line. Now what happened here? You see here, 50 is above the line and 50 is above the line. And they are corresponding angles, and immediately I know that the pair of corresponding angles is equal. Right, they are equal. Right, I'll move to this one over here, and that one is 50 vertically opposite angles. But you see here, in between the lines on opposite sides, alternate interior angles, they are also equal. They have the same size. I'll take another one. I'll do this one because these two, they are vertically opposite. 130. Okay, so now look at the co-interior angles. Right, on the same side, in between. They are not equal. They are equal to 180 degrees. Okay, so far we know corresponding angles are equal, alternate angles are equal, but co-interior angles, as you can see, they add up to 180 degrees. We take another one, 130. Still the same. Corresponding angles are equal. Co-interior angles equal to 180 degrees. 130, right? Now look at this. Alternate exterior angles. Alternate exterior angles like this too, equal. Right. Okay. Co-interior. Co-exterior. Look at the co-exterior angles here. 50 and 130 equal to 180. And the last one, this 50 here. Right. Still co-exterior angles. This two add up to 180. But alternate exterior angles, they are equal. Alternate exterior angles, they are equal. So I'll just write it in here. Corresponding angles, they are equal. Alternate angles over here, they are equal. But co-interior angles or co-exterior angles, they are equal to 180 degrees. Okay, so we will continue now with a worksheet. Right. Find the value of angles marked with letters. Give reasons for all your answers. You always work from the given. You see your parallel lines, your transversal, 38 degrees. Ask yourself, 38 and x, do they form a pair? Yes, they are alternate angles. So, x is equal to 38. And we write it out like this. X, 38 degrees, alternate angles. Now you can write it in. Make it a bit easier sometimes. Right, so we write that as 38 degrees. Now we move to y. Now you can see y and x, they are vertically opposite angles, so y is equal to 38 degrees, or y and 38 here, same position, and they are corresponding angles. Now I'm going to take this one here. Y is equal to 38. Y, corresponding angles, or even you can pick vertically opposite angles. You will get it right. You will get your marks for that also. Okay, so next one. We have two given angles here. Two given angles, three unknowns. Decide 74 degrees and A, do they form a pair? If your answer is yes, then A is 74. Yes, they form a pair. It's a pair of corresponding angles. So A is equal to 74. Now we move to B. Right, B. You see your two parallel lines, your transversal over there, opposite sides. So B and 30 degrees, they are alternate interior angles. B is also equal to 30. Reason, alternate interior angles. So we have B is 30 here. Now we continue with C. Right, and we see the common vertex here, over there, which mean, and we see also the straight line, which mean that these three angles add up to 180. And that is the way we are getting C. So C plus 30 plus 74 degrees is equal to 180 degrees. Angles on a straight line, we subtract, and C is equal to 76 degrees. Okay. Find the values of angles marked with numbers. Give a reason for each answer. So we decide now. 68 and 1, do they form a pair? Yes, corresponding angles. So C is equal to 68 corresponding angles. So I have it here, 68 degrees. Angle 1 and 125, do they form a pair? Right? No. No. 125 from this parallel line to that line there. This is our transversal. So the alternate 125 is alternate to this angle here. Right. From the parallel line to the transversal, from the parallel line to the same transversal. There we have a pair of alternate angles. So 68 plus 2, or 2 plus 68 is equal to 125. Alternate interior angles. Can we work it out? Angle, remember, always reasons, and we subtract, and 2 is equal to 57. Right. Now number 3. 3 and 68. Right. 3 and 68. That looks like they're corresponding angles. This one is on the left-hand side of the line. That one is on the left-hand side of the line. But because these two lines, they are not parallel, so angle 3 is not equal to 68. Right. It must be next to parallel lines. Both of them must be on the left-hand or right-hand side of two parallel lines. But these two, they are equal, you see? Vertically opposite angles. So angle 3 is equal to 125 vertically opposite angles. Right. Now we move to number 4 here. And decide 4 and 115, are they, do they form a pair? Right, they form a pair, but not, the lines are not parallel, although it looks like a pair of alternate angles here. Right? These two lines are not parallel. No, we can't use that. No relationship. So 4 and 54, you see there? Both exterior alternate angles and both outside the parallel lines here. So 4 and 54 degrees, exactly the same. Why? Alternate exterior angles. Right, so we move on. Let me just write it in quickly. 54 degrees. Now we can go to 5. Now you can see 5 and 115, they are corresponding, both above parallel lines, so they must be equal. 5 and is equal to 115 corresponding angles. Right, so we have there 115 degrees. Now we go to 6. Right, and 6 is the adjacent angle of 54. Right, so 6 plus 54 degrees equal to 180 angles on a straight line. Right, and you can see here we have two lines and one there. These two angles, they are not 6 and 5, they are not equal to 180, although you can call them, they are co-interior angles. Again, because these two lines, they are not in between two parallel lines. You see, they're not in between two parallel lines. For that reason, angle 5 and angle 6 is not equal to 180 degrees. Right, we have everything here? Yes. Find the value of BEG. BEG, vertex B. So it's this angle here. Okay, right. 105 degrees and BEG, do they form a pair? Yes, they form a pair of co-interior angles, and we know co-interior angles, they are equal to 180 degrees. And that's the way we go about this. Angle BEG plus 105, 180. Co-interior angles, subtract, and BEG is 75 degrees. Right, over there. Now we must find CED. CED, this one here. Now please, you cannot subtract 75 degrees from 180 because you see a straight line here. There's still an angle in between these two. So we can't use angles on a straight line. But here we have a parallel line, a transversal, another parallel line, opposite sides, and we have alternate angles here, alternate interior angles. So what CED is equal to 80 degrees. Alternate interior angles. Number 4. Find the value of x, y, and z. Give a reason for your answer. In this figure, we do not have x, but we have a y. You know that this angle and that angle form alternate exterior angles, so they are equal. And we make use of equations here to get to the answer. So 3y plus 10 is equal to 100. Alternate exterior angles, and we go about it like this. 3y is equal to 100 minus 10 degrees. We get our 90 degrees. So 3y is equal to 90. Divide each side, divide by 3. And y is equal to 30 degrees. Right. Then we want z. And you can see z and 100, they form a pair, both above the parallel lines on the right hand side, and they are corresponding angles. So they have the same size. Z is equal to 100 degrees, corresponding angles. Next one. B, here we have a x. Right? We know that these two angles add up to 180 degrees because they are co-interior angles, and we use that equation. X plus 3x, 180 degrees, co-interior angles. Add that 2 together and we get 4x is 180. Divide each side, divide by 4, and x is equal to 45 degrees. Now I want y. But x and y, they do not form a pair. 3x and y form a pair. You can see there, they are vertically opposite angles. So we must find the value of 3x first before we can find the value of y. So you must include this step here. 3x is equal to 3 times 45 degrees. And that is equal to 135. And for that reason, y is also equal to 135, vertically opposite angles. So we have here 135 degrees. Right. We get to our last one. This 80 degrees and 5x minus 20. Do they have, or do they form a pair? Yes. A pair of corresponding angles. You see there, 80 is equal to this angle here. This angle is exactly the same size as this 80 degrees because they are corresponding angles. And we start, 5x minus 20 is 80 degrees, corresponding angles. Same thing, 5x is equal to 80 plus 20, 5x is 100. Divide each side by 5, and x is equal to 20. Now I want this angle here. From the transversal there to the parallel line. Now this, from that transversal to that parallel line, that is 1. And you can see this 3 angles here. They are co-interior angles. So y is from there right over to the parallel line. So y must be 100 because 80 plus 100 is equal to 180. Why? Co-interior angles. So we start by saying y plus 80 is equal to 180 co-interior angles. And y is equal to 180 minus 80 degrees, and y is equal to 100 degrees. Now that is all for you for today. If you didn't understand the concepts in this lesson, please watch it again. Right, you can watch it silently by muting, or you can pause it to understand some key issues in here. Thank you so much. Right.